Hello, Mario. In this vocational video, I'm going to show you how to solve a trigonometric equation. And here's the equation. 3 sine 0.5t plus pi by 2 plus 2 equals 3. For the range pi less than or equal to t less than or equal to pi. Give solutions. There must be more than one because they don't make these grammatical errors such as this. Correct to 2 decimal places. So let's see what happens. So it's very difficult to solve the t when it's inside the sign. So what we're going to do is let x equal 0.5t plus pi by 2. But just before we do that, we can quite easily see from there that t equals x minus pi by 2 divided by 0.5. So the range of x's when t equals negative pi, range of t, x equals 0.5 times negative pi plus pi by 2, 0. And when t equals pi, x equals 0.5 pi plus pi by 2, and that equals pi. So therefore we can say that the range of x is between 0 and pi. So that's all well and good. Right, so let's solve 3 sine x plus 2 equals 3. And we can see that sine x equals 3 minus 2 all over 3, which equals a third. And if we go to our calculator, x equals sine to the negative 1 a third. Easy peasy stuff. We've done that before. And therefore x equals 0.340. And we're also going to make that theta, because theta is in the formula on the formula sheet, rather than using x, which isn't. So we've just made that equal to theta. So it's no biggie. So here's the formula sheet. Says that the other solutions of x, remember, give solutions, so there's more than 2. The other solutions of x are x equals n pi plus negative 1 to the power of n theta, which in this case is 0.34. So that enables us to produce this little table, and we need to get our maurieo. Oops, Control Z there. Oh no, it doesn't want to do that. There we go. We want to get we'll lock that in place. Lock it. That's locked, and now we can move maurieo. Oh, there's squares we can't move maurieo. Here's the webcam. There we go. And we can move him. We'll just move him over to there. Just out of the way there. Oh, look. Fits just there. Bloody marvellous. Okay, so then that gives us a little table here, which we can... Our first example there is when n equals 0. That's our first one. And x equals 0.340, which is what we've just worked out. And we can see, if we put that t will be negative 2.46. And that's in the range for t, so that's really good. Then we can go to n equals 1, and you can see that x equals pi, n pi is 1 pi, plus negative 1 to the power of 1 times theta, which is negative 1 to the power of 1 is negative 1, and 0.34. And we take that all away from pi, and that's going to give us pi minus 0.34, which is plus 2.46. And so that's our second solution. And then we look at when n equals 2, and that's way out of range. We can see that's going to be out of range. So that's, yeah, bloody marvellous. So that's all our solutions there. That's it done. It was quite easy. So I tried to do this in a tutorial on Friday, and I think I left out the vital part about rearranging or changing the range, or working out the range of x, and that's just made it so easy. So yeah, if we work at things long enough and we try them and we think about them and have a good think, we can find simpler and easily understood solutions. So when at first we don't succeed, try again. And I certainly have, well, I made a real, mistake first time round. So let's just analyze that a little bit further. And what we'll do is, I've got here, if we can get out of this PowerPoint here, and we can go to Google, and we'll go to Desmos. Desmos is a
opening web page.
It's a graphing tool. I'm just turning off my phone there. It's a graphing tool, and here it is here. Just click on there, and graphing calculator. Now this is also, you can also get this from the Moodle site. So I'll just move myself a little bit over there so that I'm not totally out of the picture. So now what we can do here is we can put in our key in our graph, or our function 3. So we're going to put that in there, 3, and then down the bottom, why isn't that fitting in there? Oh dear. Here we go. What's happening there? 3, and I thought I had down the bottom. Oh, here we go. This is better. Yeah, 3 and functions. Sine. Here's sine. Just come on, there it is. Yes, 3 sine 0.5. Now we can't. I don't know that we can use t. I'm going to use x. 3.5 x there, plus pi by 2, and we've got in here pi divided by 2, and we'll close that bracket. I'll just make sure we're there. Close the bracket, and then we just put that in there, and then it's minus 1. Minus 1, I think we had minus 1, and that's our graph there. But we wanted to look at it between, so that's our main graph that we've put in. It's drawn that up, as you can see. It's a periodic function. Now we needed to look at it from minus pi, so I'm just going to put is it going to be x? Yes, x equals negative, and we'll just put pi in there. And that's a line there. That's a line coming in here. It's a line there. And then this one here, we're going to have x equals pi. Here it is. Here's pi. And yeah, we'll put that in there. Right, so this is now becomes our area of interest. And what we can see here is that these are our two solutions here and here. Here's our range. Here's our two solutions. And if we zoom right in, carefully, 2.46 which is sort of what we got at that end, minus 2.46, and we just bump it here, and then in here we could go in there if we so desired. Minus 2.46 again. And so we can see here with the help of the curve that, yeah, we're pretty right, and get a bit of an understanding as to how it all works. So I'll just try and, oh, what's happening here? It seemed to be performing quite to my satisfaction here. Oh, here we go. We're getting closer. Oh, it's a bit better. And you can see in here that this little bit here would be the 0.34 there, and possibly there. I don't know what's happening. Yeah, I think it's totally lost its scale. So, yes. So I'm going to call it quits there. Maybe we could drop back to here. That might be the way to go to the PowerPoint. No, oh, here's the PowerPoint here, and slideshow from current slide. Oh, here we go, and there's all our solutions. They're there like so. So, yes, that's a bit of a solution to that problem. I hope it's now a little bit clearer. If it's not clearer now, well, you need to perhaps contact me and we can do some more work on it. Enjoy yourself. Bloody marvellous.